Section 1.1, real numbers. Let's talk about counting numbers. When you count, if I said to you, how many kids do you have? When you start counting, you don't go 0, you go 1, 2, 3, 4, and so forth. These are the counting numbers. These have a name. Anyone knows what we call these? They have a mathematical name. Begins with the letter N. Natural numbers. So a lot of times we use the symbol or the letter N for that. Natural numbers are 1, 2, 3, 4, 5, and so forth. Does not have 0 in it. Natural numbers don't have negative values. Begins with 1, it goes all the way to infinity. If you go and add the 0 to that list, if you include the 0 to that, it becomes what we call whole numbers. Whole numbers are 0, 1, 2, 3, 4, and keep going. So it's really this set, except add the 0 to it, and that's what we call whole numbers. Next set, what about if you add negative numbers? Those we call integers. So integers, that's the letter I, like -4, -3, -2, -1, 0, 1, 2, 3, all the way to infinity. So both of these are called integers. So if we take all these numbers and we represent them with this line, for example, this line represents all these numbers that we have out there. This is the 0, this is the 1, the 2, the 3, the 4, the -1, the -2, the -3, the -4. When we talk about natural numbers, I'll slow down a little bit so you can finish writing. So if these are all the numbers on the planet, so the natural numbers, only these dots, the one I'm going to just touch, just these little dots. So really a tiny, tiny group of all the numbers out there. It's only this spot, this spot, this spot, that spot. That's what the natural numbers. It's a tiny group of this set there. If you add the 0 to that, you have the whole number, still a tiny group. You're missing all the stuff in between, all the negative ones. And when you add the negative values, again, we're still talking about a small, small group of that set there. What about all the ones in between? So now, the numbers to the right of the 0, just the 1, the 2, the 3, and the 4, these are called the positive integers. And the numbers to the left of the 0, the -1, the -2, the -3, the -4 are called what? The negative integers. 0, it's neither. 0 is not a positive or a negative. Now, if I take the 0 and add it to the 1, 2, 3, 4, what do we call these? Whole numbers, right? 0, 1, 2, 3, 4 are called the whole numbers. Also, a lot of times we call them non-negative integers. Non-negative. And if you take the 0 with all the negative values, including the 0, are called non-positive integers. Sometimes you hear this terminology. You'll find out when I talk about a subject, I don't just talk about what's in the book. I get carried away with it. So I don't know if you'll see non-negative, non-positive in our book there. you know. So what about this line? What about the decimal points in between? Let's talk about another numbers called rational numbers. Are we good with this? So what are the rational numbers? That's really what this section is about. So before I talked about the rational numbers, I wanted to make sure I discuss the other ones. Well, the definition of rational number is any number that can be written in the form of A over B. Any number that you can write as a fraction, as long as what? B does not equal to 0, because when you have a fraction, you can't divide by 0. So let me go back to my list of numbers. Is the 3 a rational number? We know it's a natural number. We know it's a whole number. We know it's an integer number. Is it also a rational number? Can you write the 3 as a fraction?
Yes.
3 over what?
Anything?
Nope.
3 over 1.
3 over what?
1.
1. Yep, 3 is a rational number, because you can take the 3 and write that 3 over 1. You said over anything. If you wrote 3 over 10, it's not a 3, it's 0.3, right?
Yeah.
3 over 3 becomes 1, so it changes value. So any number you can write over 1. So 4 is a rational number because you can write that 4 over 1. Negative 5 is a rational number. You can write that negative 5 over 1. So all these dots that you see here are rational numbers. Also the ones in between. Notice we never looked at the ones in between. Let's take a look at them. What is the 1.2? Somewhere here, right? That's a 1.2. Is the 1.2 a rational number? Yes, it is. Think about pre-algebra. You can take a decimal number, change it to a fraction. How do you change that decimal number to a fraction? You can write that 12 over 1 followed by zeros. How many zeros? Well, how many digits I have to the right of the decimal point? 1. 12 over 10. I can simplify that to what? 6 over 5. Is that a fraction? Yes. Is the bottom 0? No. Perfect. So 1.2 is a rational number. 2.5 is a rational number, because you can write the 2.5 as 2,5 divided by 1 followed by 1 0. Now simplify that. That's what? By 5? That's 5. By 5, that's 2. That is a rational number. Negative 0.42 is a rational number. You can write that negative, change the 0.42 to a fraction. That's 42 divided by 1 followed by how many zeros here? 2. Can we simplify that? We can divide by 2, right? By 2, this is 21 over 50. Yes, that is a fraction. The bottom is not 0. That is a rational number. So almost, I said, all the numbers are rational numbers. There's a few exceptions. So a rational number, another way of saying it, is any number that you can write as a fraction, or another way of saying it, there we go, rational number if we're talking about decimal numbers, is any number you can write can be written as a fraction, a over b, where b is not 0. So if you can write the number as a fraction, it is a rational number. And if you don't want to worry about that, any decimal number, if it's a decimal number and you don't want to have to worry about how can I change this to a fraction, any decimal number that repeats or terminates is a rational number. So let's think about this. Repeats or terminates. Let me take this rational number, 2 over 3. Is that a rational number? Yes. So if you divide that number, 2 by 3, again, going back to pre-algebra, 2 is less than 3. So you put a decimal point, and you add a lot of zeros if you want them. You know you have them. So you can't divide the 2 by 3. How about 20 by 3? 6 times 3 is what? 18. Bring that 0 down. 20 by 3. 6 times 3, 18. 20 by 3, 6. So you notice that number is what? 0.666. It repeats. Any decimal number that repeats is a rational number. Rational number. I forgot the L there. Any decimal number that repeats is a rational number. Any decimal number that terminates, like this one has an end to it, is a rational number. Is there numbers that doesn't repeat or terminate? Absolutely. These are called irrational number. Irrational numbers is any decimal numbers that does not repeat or terminate. It has no end in sight to it. An example, pi. Now, in pre-algebra we use 3.14 for pi. I teach a class called Mathematica. In it, I ask the machine every once in a while for fun, give me pi to 1 million digit decimal places. And you'll see pi to 1 million, no repeat. There is no end in sight for pi. It goes on and on for 3.14 and keeps going. So that is a irrational number. E, another crazy number in math. 2.71828, and it keeps going on and on. It doesn't repeat or terminate. Those are irrational numbers. The square root of 4, the square root of 2, not 4, I'm sorry. The square root of 2, square root of 4 is 2, is irrational number. Our calculator gives about 7 decimal places, but it really keeps going on and on. So those are actually called irrational numbers. So that's what they want us to know, these numbers here, irrational numbers, rational numbers, and so forth. Now another topic in this section let's talk about absolute value. So the definition of absolute value, the way it's written usually, the absolute value x, we write that like this. Any of you ever seen the absolute value? You know what the absolute value is? What's the absolute value of 5? 5. What's the absolute value of 7? 7. What's the absolute value of minus 3?
3.
Now, why is it positive? What is the absolute value?
Isn't it the spaces away from 0?
Exactly, the distance away from 0. I like that answer. He said, isn't it the distance or the spaces away from 0? And distance is always positive. How far the minus 3 from 0? 3 units. How far the 7 from 0? 7 units. So the absolute value always positive or 0. Because what's the absolute value of 0? How far the 0 from 0? How many units? 0, right? It's not far away from it. So the definition of absolute value says when the number is positive, you leave it alone. But if the number is negative, you take the opposite to that. So the absolute value of negative 3 is the opposite to negative 3, which is 3. The absolute value of negative 50, what is the opposite to negative 50? 50. The absolute value of 701 is what? 701. Very good. The absolute value of negative 413 is what? 413. So the absolute value is always positive or 0. So basically, if the number is positive, leave it alone. If the number is negative, change it to a positive. So what about this one?
-2.
Why negative 2?
Because the negative sign's on the outside of the absolute value.
Very good. She goes negative 2 because, here's the minus sign. She goes, the minus sign is outside the absolute value. Let me find the answer to this. What is the answer to that? 2, and the minus sign is sitting in the front. So that's why the answer is negative 2. A lot of people want to distribute that in, just like if it was parentheses. It doesn't work that way. You got to find the answer to this first, then leave the minus sign in the front. The absolute value of negative 1/3 is what? Positive 1/3. If the number is negative, take the opposite, change it to a positive. The absolute value of 2.4 is what? 2.4. The absolute value of negative 5.6 is what? Good. You got it. And I think it might be the last piece in this section that's comparing numbers. What's the symbol represent? What is it? Greater than? He said greater than.
This one's less than, right?
Less than. Why less than? If you can't really remember them, look at this. Let's write less, capital L. See, it looks like the L. That's less than. This one. Greater than. Right, capital G. Watch this. See that little piece here? It looks like greater than. Some people remember with the Pac-Man. This one is what? Less than or equal to. or, so notice or, equal to. This is what? Greater than or equal to. We'll talk about the or. And two more. But one more. What's this?
Not equal.
Not equal. Let me first go and define the word or. Yes? Question? No? Let's say you get in trouble at home, and mom is really mad at you. You took the keys and went somewhere, and mom is not happy with you now. So she goes, okay, your punishment today, you either stay home, you can't go out tonight, or clean the garage. The shed, the garage, whatever. Let's say shed. Go clean the shed. What does that mean? You can go out if you want to. Or you can have the car if you do one of these two things. Either stay home tonight or clean the shed. If you stay home, did you complete your requirement?
No,
Why not?
because if you stayed home, then you didn't clean the shed.
Well, it says or. It didn't say and. With or operation, you only have to satisfy one of the two conditions. So the statement will be true if you either do this or do that, or if you've really been bad and you want to get on the good side, you'll do both of them. So for an or operation to be correct, that means this one has to be true, or that one has to be true, or both of them. So if this is true and this is false, your result's still true. So as long as you do one but you don't do that one, that's fine. If you don't do this but you do this one, then that's good. That's true. Or you can do both. So as long as you satisfy one of the two conditions, you complete actually your chores. Mom can't complain. The only way you can't do the stuff if both are false. If you decide, I'm not going to stay home and I'm not going to clean the shed, then you're in trouble there. So with an or, if it was an and operation, then I'll give you that. Both have to be true, but not with an or operation. Again, just like if I said to you, and I'm recording this, I'm going to be in trouble, to get A in the class, and this is a joke, so A in the class, so don't go. He said that on the video. I'm saying it's a joke to make the point. You have to have an average greater than 93, or give Z $500. Joke, just making sure. Okay. That means you can walk in and say, well, you know what? I paid $700 for this class. Never mind. Z, there's your $500. I'll see you next semester. I have to give you the A. Because the deal was you will get A in this class if you do this or you do that. So if you don't have the $500, fine. You have to have an average more than 93. As long as you satisfy this, I have to give you an A. Or if you satisfy that, I have to give you an A. Or if you go, you know what, I really had fun in the class, I got a 95 average, but I want to give Z 500. You still get A in the course. So the or operation, you only have to satisfy one of the conditions. So when we say is 5 less than or equal to 5, is that true or false?
True.
True, because you only have to satisfy one of the condition. Is it equal to? Yes. Is 5 less than or equal to 6? Yes. Why? It is less than 6. It's not equal to, but you only have to satisfy one of the conditions. Is 7 greater than or equal to 4? Yes. Where people get in trouble with negative numbers. Again, let's put the number line here. 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. The number on the right is always bigger than the number on the left. The number on the left is always smaller than the number on the right. So if I write -3 and -5, and that says, put the right operation, compare them. Is -3 smaller or bigger than -5?
Bigger.
Bigger. Notice there's the -3 and there's the -5. Which one on the right? -3. The one on the right is always bigger than the one on the left. So I can say -3 is bigger than -5, and that's true. Or I can write that -3 greater than or equal to -5, and that's also true. So I can write it either way. So both are correct. -2 and 0. -2 and 0.
0 bigger.
So -2 is less than, right? I can say -2 is less than 0, or -2 is less than or equal to 0. Both are correct. And that's how we compare numbers. Now you might be wondering, where do we deal with negative values? Oh, we deal with them all the time. Where's my iPhone? I'll show you some. Here we go. Let's see, the weather. I saw that's supposed to be in the negative color days coming up. Well, I guess not in Springfield. Let's see somewhere else. Maybe Wilbraham. Nope. There's no negative weather this week. New Haven, maybe.
Try Alaska.
Yeah, Alaska, that's right. So there are some places where the temperature is below 0. You have some negative values. So we do deal with negative values. Or when you borrow money, you don't have that money. You owe me that money. That's a negative value.